All right, so here we go. Number one, we're on page 149 in your workbook. Number one is 2, 3, 4, 5, 6, 7. Those would be the first 6 terms. 2, 3, 4, 5, 6, 7. Number two, Yao Ming, what would number 2 be?
3, 6, 9, 12, 15.
Very good. 3, 6, 9, 12, 15, and 18. Roach, how about number 3? Perfect. Exactly right. -3, -6, -9, -12, -15, -18. Number 4, Couch.
4, 7, 12, 19, 28, 39.
Very good. Exactly right. All right, this one gets a little tricky, number 5, with the fractions. Okay? Remember, you're never going to leave a fraction as 4 over 8. All right? You would always reduce that to 1/2. Okay, so having said that, TK, try number 5.
10, 5, 10 thirds, 5 halves, 2 and 5 thirds.
Exactly right. 10, 5, 10 over 3, 5 over 2, 2 and 5 thirds. All right? And then the last one, Taylor.
1 third, 1/2, 3 fifths, 2 thirds, 5 thirds.
Exactly right. Perfect. Questions? Any questions over those? All right, let's talk about 7, 8, 9, and 10. All right, number 7. It says, describe the pattern. Somebody describe that pattern in their own words.
Plus 4.
You're adding 4 each time.
It's 20.
Okay, so then it says, write the next term. What would the next term be? 20. Very good. And then what is the rule? A sub n equals 4n. Very good. All right. Number 8. What is happening there? What's the pattern? 4 is being added. Right? 4, 11, 15, 19. 4 is being added. What is the next term? 23. And then the rule would be what? 4n plus 3. I think we did it on the board. I think it's the same one that was on the board a second ago.
Really?
All right. Now let's talk about 9. On number 9, you got -3, 6, -9, and 12. You're oscillating the positive and negative. Okay? That means going back and forth, oscillating. So in your own terms, it's increasing by 3, but then you got positive and negative. So it's really not increasing by 3. All right, so what would the rule be? We talked about it. What would the rule be here? Or we talked about it in the math team, sorry. 3n.
3n. 3in times -1.
All right, so here, let's look at this. Everybody, eyes up here. If I took the negatives off, would 3n work? Yes. So 3n would work. So we got to somehow figure out how to make the first term negative. Then the second term was positive. Then the third term was negative, and so on and so on. The way we do that is we tack on a -1 raised to the n power. You probably wouldn't have known that right off the top of your head. Okay? So -1 to the first power is what? -1 to the first power is what? -1. That gives you -3. -1 squared, the second term, gives you what? +1, which is going to give you a +6. -1 to the third is negative, and so on and so on. So I say again, what was the next term? I don't know if we said it. What would the next term be? -15, right? How did we get that? The 1, 2, 3, 4, the fifth term. I put a 5 there and a 5 there. 3 times 5, and then -1 to the 5th power. 3 times 5 is 15. -1 to the 5th power is -15. Okay? Questions? All right, how about number 10? 3, 9, 27, 81. Corey, what do you think?
243, 8.
All right, 243 is the next term. What's the pattern in your own terms? In your own words, what's the pattern? You're increasing by what? You're multiplying by how much? 3. Each term is being multiplied by 3. So you're adding a times 3. So how do we say that? What's the rule going to be for number 10? A sub n is what? 3 to the n power. Raise your hand if you got that right. 3 to the n power. Very good. The first one gave you 3. The second one gave you 9. The third one gave you 27, and so on and so on. Okay? And that's how you got 243 for the fifth term. All right, let's look at number 11 together. See, you can turn it off. Let's look at number 11 together. 1 over 11, 2